actually C++ and Java are almost same. Okay, so we will go through some part of the basics of Java, and then we will go through the bit more advanced part. Okay, so in this Java programming sessions or Java programming part, I might not be able to do all the programs, but I will share the programs or I'll share the slides in the classroom in which you have all the programs. And another good thing about Java is not like in C++, we need to have an IDE where you type the code in that software and run it and etc. etc. In Java, you don't need that. You can just put it in a notepad, type it, and you can execute from the command prompt. And in Android's version also, you have a lot of software available. You can download it to your phone, you can type it and get the output, which was difficult for C++. Okay, so I will also tell you what are the possible applications in Android and in PC or online where you can type in your Java program, test it, and check your output. So we will not be having any assignments on Java. So Java is mostly will be a theoretical part, Java and Android. So C++ we'll continue with some more programs in C++ parallelly also. Okay, so the first thing about Java, I think everybody knows that, or most of you have heard of this Java and its description from the film Premam, where the teacher is telling about what are the properties of Java. Java is robust. Okay, but if you tell about the history of Java, Java was developed by James Gosling of Sun Microsystems. Okay, Sun Microsystems is a very famous company. They have a lot of softwares developed, and they have their own OS at one point of time, but currently they are not that much. Actually, it was acquired by Oracle. Okay, so James Gosling introduced, actually he was the project lead in that team where people work to create a new programming language. So that's why he's the one which we say as the developer of Java. Now Java name is actually from the island Java in the Indonesian islands. So why they give the Java name? It's because it is the island in which, or it is the place at which you will get the best coffee. So you can say the best coffee or the best programming language is Java. And actually, initially the name of Java language was not Java; it was something called as oak. Oak is a tree. Then they changed it to Java after some discussions. Okay, and I don't know whether you have seen this, but so currently all your mobile phones are Android based, okay, or Windows or iOS, okay. But there was a area, or there was an era in around between 2000 to 2010 where all the mobile phones were Java based. The OS, the operating system, it was Java, and everybody had such a mobile phone before Symbian started or Android started. Okay, so I also had a couple of phones with me. Still, I have, which works on Java. So, and Java is widely used everywhere in the world. Like it's one of the 10 best products of 1995, but it's still being used. So Java has advanced much more. Like you have heard of JavaScript, which is used in web applications, and there are a lot more what you call evolved languages from Java. Even I can say Python is some kind of evolved from Java. So Java formed the basic of many of the object-oriented programming languages. Just like the the C language was the basic language for all the programming language. Java formed the basic for all the object-oriented programming language. So it is used in Windows applications, web applications, enterprise applications, mobile applications, cards, and newer and newer features of Java is being added every day. Okay. In the features of Java, you can see around 12 of them. Actually, it is much more. So first, being object oriented, it's very simple. So why I say simple? Because if you look at C++, let's say you want to find the uh, list of Fibonacci numbers, then you want to write the complete code using a for loop to print the Fibonacci numbers. But in Java, you have a function, just call that function to just print the Fibonacci numbers. So the how you program or how much learning time you need to learn Java is much less. Now it is secured. Now security is something I don't know whether you understand it now, because once you have a code or a program running in any of the machines, nobody should be able to crack that code, or nobody should be able to alter the code to make it work in their own way. So Java has many security features. For example, in your class, you say you can declare something as private, right? Now, private is actually a security feature, because if you have declared something as private, and if somebody else who doesn't have that complete code will not be able to access any of the private variables as well as secure. Platform independent, that is a very important part, because Java can be run in any operating systems, regardless of what operating system you are using, without any problem. Just I said I'll demonstrate that to you what is platform independence. It's robust. Robustness means that even if you try to change something in Java, it will not affect anything else. It's called as robust. Like കുലുക്കമില്ലാതെ നിൽക്കുക എന്നുള്ളതാണ് robust. It's called as portable. Portable means that you can copy paste the Java code and put in some other machine and it will still work there, while this will not work in C++. Architecture neutral. Neutral means like doesn't matter which processor you are using or what type of architecture your processor is having, it will work. It's dynamic, interpreted, high performance. It is very fast and it's multi-threaded distributed. Multi-threaded means you can have multiple threads in Java. We'll discuss all these things. And it's distributed means you can have multiple Java programs running in multiple machines, but all that output can be combined and give a final output to you. So even if the Java programs are running in different machines, you still get a combined output. So today's class is mostly regarding the features of Java, etc. So it is mostly theoretical. We might not be doing any coding, but let me see if I can do something. So I'll just read through it. So Java is simple. It is easy to learn. Syntax is simple, easy to understand. And Java syntax is based on C++. So if you know C++, then you can easily learn Java. It's object oriented. So just like we have seen in C++, we have objects for each class or for each type of program. You have an object in Java also, or you can create objects in Java for data and behavior. So the basic concepts of OOP, which are object, class, inheritance, polymorphism, abstraction, and encapsulation, are there in Java also. So the most important feature of Java is platform independence, which means that regardless of what hardware you are using, regardless of what software environment you have, the program still works. Now, Java platform differs from other platforms is in the sense that the software-based platform that runs on top of other hardware-based platforms. So you have a hardware platform, for example, your processor. Everything runs in the processor. But for Java, it is actually, it creates a software layer over the hardware, and then over that the program runs. Okay. So it can run in multiple platforms like Windows, Linux, Sun Micro, Solaris. Solaris is the OS of Sun Microsystems, Mac OS, etc. And the Java code is combined and converted to something called as a bytecode. And bytecode is platform independent. Bytecode is actually a machine language code, so that independent of any platform, any machine or any processor can read the bytecode. In C++, we will not create a bytecode, but in Java, we will be creating bytecode. So as I said earlier, it's secured, it is robust, it's a very strong memory management, and there is no pointers in Java, so there is no security issues. There is something called as Java virtual machine. which is a bit more intelligent uh, compiler, which or interpreter, something we call something like that, and then which helps you to run Java without much change in its performance. So architecture neutral is portable, as I said, high performance. It is very fast. Distributed means that it can be run in multiple machines, but you can still get single out. Multi-threaded means that a single program can be run parallelly, and each parallel instance of that program is called as a thread. So this is a bit more advanced concept, but we'll see that. So you can write a program in which you can say to the operating system that you run this program in 3 threads. You run different part of the program in 3 different threads, and all the 3 threads will be running parallel at the same time. Okay, and it is very fast. It doesn't occupy too much of memory, etc. And it's dynamic, means suppose a dynamic loading of classes, and there is no garbage. There is garbage collection. So this is a comparison of C++ and Java. This has been asked a good number of times in our semester and examination. So you can just read through it. I'm not going to. Okay. Now coming to the main parts. Okay. Now how will you give an output, or how will you generate an output? What are steps in giving an output to Java code? First one is you have a text editor in which you will write the code. For example, Notepad, Notepad++, etc. And save it as .java file. So extension of a Java code is .java file. So that is your Java source code. Now, once you have Java source code, you can compile the code using the command javac, which will convert the code into something called as a bytecode. Okay, and it will give an output file called as .class file. We'll see. I'll demonstrate that to you how that is happening. So the compilation will give the file called as .class, and if you run this file using interpreter, you will get the output. Okay, so this .class file is actually a bytecode. So if you open that file, you will not be able to read anything from that file because it is mostly ones and zeros. It can be understood only by the machine, which is the processor. And once you do the Java command, then this is actually the interpreter. Okay, so the compiler in Java is actually called as an interpreter. It's basically a translator which converts Java bytecodes into machine code. So the bytecodes will be converted into machine code, and the machine will read that machine code to give the Java program output. Apart from that, you can generate a document from Java source code by using Java doc file, doc command, which will give HTML files, or you can list the header files by Java H, or you can debug using JDB. All these are possible using Java. So let me just demonstrate to you how this is working. Okay, so let me just change my presentation. I hope you can see my screen. Okay, so I'm going to take a Notepad++. This is actually one of this text editors which I usually use, or you can directly take Notepad, whichever is comfortable. Okay, so this Notepad is also fine. So I'm going to write a code. So I'm just going to come and give a command. this is my first Java code. Okay. In Java, everything should be inside a class. So I'm going to define class, my class. Okay. Inside it, I'm going to define the main function, and the main function should be declared as public void, so public static void main. This is the declaration. Okay. And inside the main, I might there's an argument you can pass, which is not always required, but I'm just doing it. Okay. Now, if you want to print something in the output of Java, what you want to do is you want to call system dot out dot println. We'll see what system is, what out is, what println is, everything, but just be patient. So just say hello world. Okay. So this is my code. So if you see, I haven't used any of the IDE. In C++, I was taking this dev C++ and writing the code inside that. But here I am just writing in a normal notepad. I'm going to save. I already have temp.java. So the save, when you save the file, you should save it as .java. Okay, so you give the name .java. Okay, so I save the file. Now what I can do is I can go to my command prompt. I don't know whether you have seen this. There's a command prompt for Windows. This is actually your access to the Windows internal things. Okay, you can use commands to access many of the internal things. Okay, so I'm going to my folder where I have kept my file. So if I list my directory, you see that there's a file. Okay, let me just remove my class. Okay, so you see in this directory I have temp.java file. Okay, so what I'm going to do is, if you have looked at our presentation, I can compile this file using Java C command. So Java C temp.java. If I do this, it will compile the code. It will not give me an output, but it says if there is an error, it will share the error. For example, I'm going to purposefully make an error. So I'm just going to remove this semicolon. So now it says that there is a semicolon expected at some lines, and there's an arrow mark here which says that there is no semicolon. Okay, so Java C is basically you are going to compile the file. So once you compile this, it will create a temporary file or the bytecode file called as myClass.class. And you see, my class is actually the name of the class that I have created inside my file. So it will create a class file with the name of the class you have declared inside. So if I go to the folder, there's a my class file created. So if I try to open this file, you see that you can't read anything. There is something, given something, etc. So this is basically called as a bytecode. Okay. So the byte class file, my class.class file is created. Now you want to see the output. Okay. So if you want to see the output, you can just say Java temp.java. When you say this, actually the my class.class file is being fetched and it is run. So when I do this, you can see that it has printed hello world. So that is my output for this program. Okay, so it's a very simple program in which I have used this program without accessing any of the IDEs, without accessing any other resources. I just use a notepad and my command prompt in my Windows, which is also present in Linux, to run this program, get the output. Okay, but if it was in C++ or in C, you need to have another software called as IDE, in which you want to write the code, compile this, and run this in that software only. You cannot use any of the Windows parts, right? So this is what I am calling it as platform independent. Now, if I copy this myClass.class file and put it in, let's say, a Linux machine, an Ubuntu machine. And if I again do uh, Java space my class dot class, it will run there also. That is why it is called as platform independent. You don't want to compile it again in Linux. But if you are doing C++ or C, you need to compile it again. Then you want to generate the output. Okay, so that is called as platform independent. Right. Now, if you come look at the, let's check this code first. Okay. So this is command. So command can be done as /* or //. Okay. Or //. This is also command. Fine. Now, I declare a class just like in C++, class space name of the class. So this is class, this is a keyword, and my class is the name of the class. You put inside two curly braces whatever is to be done inside the class. And inside this my class, I declare a function called as main. If you remember, in C++, you have declared a function inside class. Just like that, you declare a function called as main, which is a public function, which returns nothing, and which has an input argument called as string. Okay, this is, we'll see that why we have string argument square braces. Basically, if you want to pass any argument from the command prompt, we can use this. Okay. Now, the function will be in two curly braces, open and close. Inside this, you will have, if you want to print something, you want to access the package called as system. Okay. In that, you go to the object called as out. In that, you call the function called as println, and the function accepts the string hello world, which will print. So system is actually a package. Out is a object or a class inside system. Println is a function inside out. Okay. We'll see why the static is there in main function. We'll see when we go further. Okay. Let's say I want to declare a variable. I can declare as int, just like you have in C++. You can declare int, char, double, float, etc. in the C. Okay. And then I can say the value of C is space. Let's say my value is 10. If you want to add anything to it, you just say plus C. Okay, this means that you first print the value of C is space, then you print whatever is there after plus. The value of whatever is there after plus. So if I do this, you can just directly say Java and .java. You see the value of C is 10. So if you haven't given anything in this double quotes, it will print the value inside that memory location. Basically, you're creating a memory location called as C and you're putting a value 10. So if when you put println, if it is not in double quotes and you have a plus sign before that, then it will give the value C. Let's say I want to print something else after C. So you put another plus sign and in inverted commas, you just say plus C is 10, which is 10. So if I run this, see, the value of C is the value which is there in C, and then which is 10. So if you want to concatenate multiple terms, you can just do a plus. Okay. If I don't put a plus here, it will give me another. Okay. So because this is a string, this is a variable, and this is a string. So I can just put it plus here. So you want to concatenate different types of variables and strings, you just put a plus. Okay. This is regarding the main function. So if you look at this except you have system.out.println and static, everything else is exactly same as that is C++, and also the main function is inside a class. Okay, I hope you have understood this. Let's check some presentations based on that. Okay, so in Java, you have keywords and identifiers just like you have in C++. Okay, so you have int, which is a keyword. You can have float, you can have um, double, etc. Okay. In the score means you are creating a variable called as score, which can take in an integer bytes of memory. Now you can have loops, for example, for or while. You can have a variable name of any name, except you cannot use any of the keyword names for or while. So these are the keywords. Keywords means the commands that is possible in Java. You can see that if is there, private, static, short, return is there, for is there, while is there, void, public, float is there, else is there, do is there, break is there. So these are all almost same as that in C++. Now identifiers are like the names that you give, that is defined by the programmer. For example, the name of the object, name of the class, name of the function, name of the variable, name of the packages, etc. And there are a set of rules that you should have keep in mind while you are naming anything in Java. Now, first and foremost, it should be alphanumeric. Alpha means it should be an alphabet. Numeric means it should be a number. So you can take any alphabet from A to Z, both big and small, or you can take any number from 0 to 9. You can use $sign, you can use underscore. Okay, but you cannot use any other special characters. You can use underscore or dollar, that's all. Now, the name should not start with a digit, because you cannot name something like one score. You cannot do that. You should always start with a alphabet within ABC, A, B to Z. So one var is not a valid identifier. Identifiers are case sensitive. So if you have score with S capital and if you have score with S small, there are two different memory locations. There is no limit on the length of identifier. Now keywords cannot be used as an identifier. For example, while is a keyword, so you cannot declare something as int while, because while is already used in the loop, while loop. So because of it, you cannot use that. Now, if you look at this, you see int my var is equal to 0. That is fine, because you can use underscore. So this is fine. Now, class my class. This is also fine. You are not starting with a number. You have alphanumeric identifier. You have keyword class. Void first func of int a comma int b. If you look at this, you see there's a 1 at the starting of the function, which is not permitted. You can have only alphabets at the starting of the function. So it should not start with a number. Double while var equal to 10. This is totally fine, because although there is while, it is with another alphabet. You cannot have while standalone, but you can have while with another alphabet or words combined. This one. Long for equal to 0. For is a keyword, which is not possible. Now, coming back to our program. So this is the whole program of, you can say, a simple program in Java, and all the program in Java is inside a class. In C++, the main function was outside the class, but in Java, everything is inside the class, including the main function. So the class is the keyword, sample is the name of the class. It should be within opening and closing curly braces. Inside the class, you can name any class for the main function. So this is public static void main string arguments. So main is the function name. Public is the access specifier, which means the main can be accessed from anywhere outside the class. Okay. Static means that actually it means that you need not create an object for the class sample to access main. Okay, we'll see that. Void is a return type, main is the function name. This is the input argument. String is array of characters. Now, similar to cout in C++, to print something in the console, you can use system.out.println. And be careful, the S of system is capital. If you write as small, it will give errors. Okay. So println is a method member to the out object, which is static member of system class. Okay. So out is an object or a class, and println is a member inside the class. This is a small program to find the square root of a number. Okay. So you see that you have the comments in star or slash star or slash slash. You can write anything in slash star or slash slash, which will not be compiled or read by the interpreter or the compiler of Java. There's a new keyword called as package. Okay. All the Java programs, you can put them in a group or called as a package. Okay, we'll see packages in more detail. So you can create, if you want, you can create, otherwise you can leave this. You don't want to create a package. So I am creating a package called as my pack, in which I'll have this program. Now, if you want to find the square root of a number, then you need to have some access to the function called as sqrt. And that sqrt is present in the package java.lang.math. Okay, so this you want to import. Import statement needs to bring certain classes or entire package into the visibility of the current program. You look at the current program. Let's say I want to use sqrt. So if I just do y is equal to sqrt of x, it will be an error. Instead, you import the package in which sqrt is defined. So import is actually a keyword which tells the compiler to go and search in the package Java. Inside it, go to lang. Inside it, go to math, and find out the sqrt function. Okay. So this piece means here we are importing the class math from the package lang. The method to find square root is present in the math class. This class is not included in Java program by default. By default, it is not included. So this import is just like you are doing hash include IO string. Exactly same. Okay. So you can declare two variables x and y. The variable type is double. Double is basically float variable. Okay. And then you access the sqrt package or sqrt function from the math class using math.sqrt. And you say, if you just put x as an argument to it, the output y will be the square root of x. Okay, so this y, whatever you get, y is equal to, that will be square root of x. And you can just say system.out.println y is equal to plus y, which will give you the value of y. Okay, so this is basically a Java program structure. Okay. So you have a main method class, which is the class we have seen in which you have defined the main function. You can have another class definition. You have interface, import, package, document. So we are going to see all other parts, which are the interface, import, package, and documentation, etc. Okay. So there are some questions at the end. You can just check that. Okay. So I hope you have understood that the starting of Java. Okay, it is not, I don't think it is much tough. If it is tough, let me know. I can do a coding on that, and you can see that by yourself. Now, before we end the session, Now I told you that you can use Notepad for um, writing Java code. Now there are many IDs also available for you to uh, run Java code instead of Notepad. So one ID I can show you. So if you look at this, I have created, or I have put a list of possible IDs that you can use in Windows if you have a laptop. One thing is Java with Eclipse ID. Now, if you want to run the Java code in online, let's say you have mobile only, and if you want to run it online, then you can go to Java tutorial point and you can use that to run the Java code. Or you can go to online GDB. Online GDB is the most popular one, or Code Chef, whichever is easy for. Now, if you want to go and let's say most of you have Android phones. So if you want to run Java code in your phone, go to Java NIDE, which is available in this link, and you can try and run the code. So the good thing about using IDE is the debugging is very easy. Okay. So I will also share all these details. Actually, this is the next slide, actually, next portion, which I'll take tomorrow. Okay. So just to show you the Eclipse IDE, let me see if I can share that. Oops. Eclipse IDE will take a good amount of time to load if you're using an old laptop. The laptop is very old, so it will take some time to load, and it will take away a good amount of RAM also. Okay, so just give me a second. Let me open Eclipse. So Eclipse IDE is a very famous IDE. I think it is also from Sun Microsystems. So Eclipse IDE, you can program Android programming, which was, I think you can use. Initially, Android was programmed in Eclipse, and then later they have changed to Android Studio. And you can do C++ programming also in Eclipse, but you need to install compilers for that, which is not an easy task. But for doing Java things, it is the best way to use Eclipse, or you can use NetBeans. Okay, so let me share the screen. I hope you can see my screen. Yeah. So if you see this is actually an Eclipse IDE, and actually I have created a project, etc., etc. If you want more details, you can let me know. I can give you how you can create a project and how you can run the code, etc. So I have just what do you call, written a code here, and if you want to compile, you just say okay, it's actually built automatically, so it will build automatically. Okay, then if you want to run, you can run this program. You can see at the bottom there is hello world, which I print here, and a plus b is equal to c, which I print here. You can also put a breakpoint and debug. So if I put a debug, you see now the program execution is here. So if I move to the next line, you see hello world is printed. And if I move next, you see the value of a is 1, b is equal to, and c is not yet assigned any values. Okay. And if I move next, you see that a plus b is equal to c has assigned value 3. And if I move next, the print a plus b is equal to 3 is printed, and that will finish the program. So all these things can be done using Eclipse IDE also. Eclipse IDE is available in both Linux and Windows. Okay. So if you want to know more regarding Eclipse IDE, you can let me know. I can let you know how you can download and how you can install these things in your laptop. Fine. So I think that will conclude our session for today. I hope I have given a very brief introduction on Java, because all these things are not part of your syllabus, but I just want to make you understand what are the possible things available in Java to do Java programming and how the main function is created. We continue with this basic things for the next couple of classes before we actually start the Java part in your syllabus. Okay. One more thing, I have added previous semester question papers in your Google Classroom. Make sure you look into that questions of the part A portion, because I will be asking questions for the series exam from that portion. Okay.